Hello. Am I audible?
Yes,
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 sir.
sir.
Yes, sir.
Sir.
Okay, so let's start this session. And by the way, how's the week 11? I mean, did you find as difficult, easy, or it's okay? Or did you find as interesting or
Did not started yet.
Sir, quite interesting
Week
and little
10
difficult.
class.
okay? What about others?
It's okay.
Okay. Okay. All right.
Sir. Hello, sir.
Yes.
Before starting the lecture, I want to ask you something.
Yeah.
Actually, I am not getting the previous recording of statistics in the calendar. It says access denied.
Access denied, correct.
No, are you talking about YouTube link or
No,
No.
no, it's Zoom meeting. Yes, Google Meet. The TA session.
Yes. Yes.
which session you are talking about? Yesterday's or today?
All the sessions.
Sorry?
Mm, all the previous recording.
No,
The
no, no,
Probably
session.
no,
on
no.
15 on
Uh-huh.
14 also.
No, no, no. You can't select able to access all the session because day before yesterday I gave the access. Maybe yesterday session I have to give the access. Okay. I will check once and so
Okay.
yesterday there
Class on
was one.
15,
Okay,
access
class one.
denied. Yes, sir.
Now can you cross check?
So it's this week 10 or week 11?
It's week 11.
Yes, sir, working, sir. Thank you.
Okay,
Yes,
so I
sir.
will start the week 11. Uh, by the way, how many of you seen any lecture video or have covered any lectures
All,
or
sir.
all are
Yes, a few lectures, sir.
Sir,
There is one more class on 14th August. Can you please provide the access for that also, sir?
Yes, sir.
where do you get the recording link and the calendar? Is that the place?
yes.
Yes, it is on the calendar.
Yeah.
It's not working for 8th August also. But you can do that later on also, sir. That's okay.
Okay,
Yes,
okay.
sir,
You can
probably at the end of the
simply,
class.
if you are facing any difficulty, right, regarding access and all, you can simply inform TA also. They will, inform me. And okay, anyway, I have given the access. No worries.
Okay,
Okay,
sir.
all right. So
Okay.
let's start this session.
Thank you, sir.
So how was the week 10 like? Was it okay or fine or any issue?
I think the content was okay. In the practice questions, we might need some help, but I'm guessing.
Sir, practice question, last question. Practice assignment, last question.
Okay, okay. Doubts I will take at the end. Okay. I will basically I
Sir,
will try to finish the concepts of week 11 first. Okay. What's the due date for week 11? 21st, right?
21.
Oh,
21.
oh, no worries. So let me start the part. Okay.
It's week 11 open session, right?
Yes.
Okay.
Uh, can you see my screen?
Yes, sir.
Great. Okay. So in week 10, okay. So in like in week 9 itself, we started with what is the definition of random variable. Then we saw what is the probability mass function. Then we saw what is the cumulative distribution function. Okay, and we saw, I mean, to be a valid PMF, there is two properties. Probability should be greater than or equal to 0, and summation of all the probabilities should be equal to 1. And these all things we have seen. And week 10, we move to what is the expectation of X, some properties related to this. Okay, and then you have moved to what is the variance and some properties related to this, means what is the variance of a constant, variance of a times X and all. Then maybe you have seen the standard deviation of random variable. Okay, so these all things we have seen. And week 9 we have seen also, like what is the discrete random variable, and what is continuous random variable, and all we have seen. Now we will see some distributions which is called discrete distribution. Okay, so we'll start from very basic distribution. So first one is called, suppose you have a scenario, I mean, you have an experiment, you are going to perform an experiment. Okay, for that experiment there is only two possibility. You can say either S, either no. Okay, suppose result of an exam. Okay, I mean, whether you have qualified or not qualified, right? So you can say qualified, right, or not qualified. Yes or no? Or you can say pass, fail.
Yes.
Correct. Then, I mean, similarly, so if you are going, I mean, you have some experiment whose outcome is only two possibility, right? Let's say normally we are saying uh, success or failure. Okay, so that some let's say you are going to toss a coin. Okay, what is the possibility? Either you will get head or tail. Correct. Suppose you are interested in head, that will be your success. I mean, suppose you toss a coin and you got head, that means you succeed, right? And if you didn't, I mean, you suppose you got tail, that means you failed. Yes or no? Are you getting my
Yes,
point?
sir.
Okay. So if
Yes.
suppose you are doing any trial or something like that, if for that particular trial, if there is only two possibility, one is called success, one is called failure, that's something named as Bernoulli trial. Okay, or we are using Bernoulli distribution. Basically for particular trial, I can say it's a Bernoulli trial, means for that particular trial I will get only two possible outcomes, one is success and another is failure. Okay, so let's say, okay, for tell me, if you are tossing a coin, suppose you have fair coin or unbiased coin, what is the probability for getting hit?
1/2.
1 by
1/2.
half, right? What is
Yes.
the probability for getting failure?
1/2.
Half, right? So can I do something 1 minus half,
Yes.
right? So how we can define this, Bernoulli distribution in general, actually? Okay. So let me write. So I will write a random variable x, is said to have a Bernoulli distribution so with success probability p, or I can say with parameter. Normally we are using this term of parameter. I'm writing here success probability p. Okay, when if its probability mass function is given by, so what will be the probability mass function? Tell me, if you have only two trial, what will be your probability mass function?
One will be P and the other will be 1 minus P.
Yeah, p will be,
Yeah.
probability p will be for success, and
Yeah. Failure will be 1 minus P.
if I want to write probability mass function, then what should I write? Can I write p raised power x?
Yeah.
1 minus p raised power 1 minus x. For what? When your x will be 0 or 1, you can simply substitute these values. 0 otherwise. I will explain in a while. Okay. So thing is that whenever you are saying success, right? Normally we are denoting as a 1 and we are denoting failure as a 0. Okay. So if you have this kind of experiment or this kind of trial, which has only two possibility, either success or failure. Normally we are denoting as a 1 success, 0 as a failure. That's called the Bernoulli trial. Now is it fine? Yes, no? Okay,
Yes,
let's say you can simply substitute. Suppose x equal to 0 means, suppose what is the meaning of x equal to 0? Means you got failure. Means what is the probability of failure? Yes or no? So it will be p raised power 0, 1 minus p raised power 1 minus 0, which is nothing but 1 minus p or not. And what is this probability? This is probability of failure. Yes or no? Are you getting?
yes, sir.
Okay.
Yes, sir. Yes.
Suppose what is the success probability? X equal to 1. It will be p raised power 1, 1 minus p raised power 1 minus 1, which is again p into 1 minus p raised power 0. Something raised power 0 is nothing but 1. It will be p. What is this probability? Success probability. Are you getting? Suppose what I'm saying.
Yes,
Suppose
sir.
you have unbiased coin. So you will say your p is half, right? Suppose you don't have unbiased coin. Let's say your success probability is, let's say p is 0.6, for example. Then I will say, my question is, what is the probability that you will get head? Then what is the probability that x will be 1? Correct?
Yes, sir.
So it will be 0.6 raised power 1. 1 minus 0.6 raised power 1 minus 1, that is 0. So it will be 0.6. I mean, basically, this is the success probability, and 1 minus p will be 0.4. So this is the probability for getting tail, and this is the probability for getting head. Okay. Is this clear? Some rough idea is okay?
Yes, sir.
Okay.
Yes,
So
I got
can you
it.
tell me any trial which is not Bernoulli?
Rolling a dice.
Unlikely events. That means both equal. If it is not equal.
Okay. Anything else? Yeah. Yeah, it's very
Whereas probable outcome are more than 2.
see
Drawn a
non-Bernoulli.
ball in box.
See, yeah, correct. Bernoulli is what? When you have only two possibility, right? Either success or failure. Yes or no? Suppose you are like, for example, you are standing in front of a mall, and you are asking the people who are entering the mall, you are asking their age. So this is not a Bernoulli experiment. Yes or no? Because see, in that case, it's not like only two possibilities. Yes or no?
I mean, depends on what you are asking. If you are looking for below 30 years or above 30 years.
Yeah, that's okay. Yeah, that's okay. So that's why I told you, right? So suppose you are asking age, I'm asking only age. So for that particular case, it's not only like only two possible outcomes, right? Are you getting? So whenever you have for your experiment, you have only
More
two
than two
outcomes. Yeah, you have only two outcomes. That will be Bernoulli. Okay, or else it's by not Bernoulli trial. So related to Bernoulli, we have something called binomial. Okay, Bernoulli is clear to all of you. So simply your x will be something like that. It will take value 0 or 1. Okay, let's say it will take value 1 or 0. And what is the probability when x will take value 1? It's p. And for 0, 1 minus p, this is something I have told you, right? Yes or no?
Yes, sir.
Yes,
Correct.
sir.
So what will be the expectation of x? Tell me. How will I calculate the expectation of x?
1 into p, 0
1
into 1
into
minus
p
p.
and 0 plus 0
Basically,
into 1 minus
summation
p.
of
Yeah.
x into
Yeah,
px, right? 1 into p plus 0 into
Plus
1 minus p,
1
which
minus
is
p.
Minus p.
t, right?
p.
what will be the variance of x? How I can proceed? Expectation of x square.
X square minus
Expectation of x whole
square.
square. So expectation of x square, expectation of x we know. We need to calculate this part, right? So what will be the expectation of x square? It will be 1 square into p plus 0 square into 1 minus p, which is again p. Correct? So what will be the variance of x? It will be p minus p square.
Yes.
It will be p.
Yes,
I
sir.
can take common. It will be p into 1 minus p.
1 minus p.
Okay. So just keep this in mind. It will be useful after a few minutes. Okay. So this is something you can calculate, right? So now let's come to the next part, which is called, binomial distribution. Okay. So from where binomial distribution you can get? Actually, so if you have an IIT trials, IIT means independent and identically distributed. Any one of you can explain what is the meaning of, or any guess this meaning of this NIIT?
Like 1 by n, 1 by n, 1 by n.
No, I want in some layman term.
Like a
Means probability is same of them and they are independent. Means they don't depend on each other, but and their probabilities are same. Individual probabilities.
Identically and independent trial, basically. Something independently or identically distributed or something like that. I'm forgetting the exact thing. So what I'm trying to explain here, identically means it should be same. Okay. Independent means all trials should be independent. Okay. It shouldn't be there shouldn't be any dependence. For example, in real life, actually, whenever you are going to collect sample and or something like that, right? We'll do in stats to in more depth, actually. So I will give you just a flavor of this why we are taking. When I mean you will see in some statistics books x1, x2, xn, these are, IID samples from something with some distribution and all. So why we are taking IID sample? I will give you one example. You will give me the answer right now. Suppose you want to do some analysis, or I mean you want to see some characteristics in the in a rose plant or something like that. Okay. So suppose okay. So you suppose so there are some rose plant, let's say one is rose plant and another is from lotus, and another you can take some lily and all. Suppose you took some samples, okay, from like this, and all are independent. Okay. Another samples you took, another one sample from rose plant, and another some second rose plant, which is independent. I mean there is no any dependency. Rose 3 and some another rose plant 4, something like that. So which sample you will you prefer to do your study? First one or second one?
Second,
Why is that so? Why not first? What's the issue with first one?
because it is of same sample, so probability will be more identical.
Yeah, okay.
Maybe like this tossing rolling a die. Probability of getting all events is same. 1/6, 1/6.
Sir, the rose, lotus, and lily, that depends upon the temperature, weather condition, and that is different if you will compare with the rose with the lotus. But in second case, the situations are identical.
Situations are identical. Actually, whatever you want to do yesterday on rose plant, right? So it's good to go with this kind of sample. All right. See, if you
All
want
identical
to,
sample.
yeah, all IID sample, all should be identical and all should be independent, something like that. Okay, that's the different things. Little bit depth, actually. Suppose you want to, find like treatment for a particular disease or something like that. So you will collect the data from previous history, something, so which should be similar to that disease, right? Something like that. Okay. So okay. Pranod has yes, Pranod, your query.
Sir, it is evident that we can consider when we collect a sample that a sample is identical. But how to ensure that it is independent? Because most of the time we are not going to collect the data, but we have to use the all existing data or the data which has been already been collected. So until and unless it follows IIT norm, we cannot proceed with any of the analysis which is based upon this particular assumption.
Actually, it's so thing is that it will depend on the objective, right? Objective means what kind of experiment you are doing. Okay, suppose you are tossing coins some 10 times. Okay, so if okay, tell me whether outcome on of the second times will depend on the first outcome.
No, sir.
Suppose you are given you have a data set of some no coin toss or something like that. Whether it will depend on the first toss.
No, sir, it will not depend
Okay.
upon the first toss because its event is independent in itself.
So if yeah, if you have something like that available data, then you can go with that. Okay. So actually that kind of see some kind of error we are finding because of these kind of minor mistakes. Okay. Suppose you have some biasness. I mean, suppose you are doing your let's say you went for any analysis or okay. Let me give you some very simple example.
Sir, tell me one thing.
Suppose
Is there any mechanism through which we can ensure that my data is following IIT?
Random procedure, right? Basically,
Okay,
you want.
so I have to go generate a random number for that particular variable, which
Correct.
I have to consider it IIT.
Yeah, actually, there are lots of method which which is not in this stats one code. This is called sampling distribution. Okay, if you are interested, I can suggest you one book which is very interesting. So there are lots of method. One method called simple random sampling. Okay, how to collect data and all. Another is called purposive sampling. Okay, and then another is called stratified sampling. Then another is called systematic sampling. So there are lots of method. I will tell you one of the examples. So in purposive sampling, suppose you want to show I mean I want to explain from where bias is coming in our final. For example, suppose you want to show standard of living in a particular city, let's say Delhi, has been increased in some past few months or something like that. Okay, and suppose the data which you have collected from rich locality only. Okay, suppose you went some if you are aware about Delhi, so suppose there are some rich locality, Mulchand, the defense colony and all, there are lots of Hoj Khas and all something rich locality. You have collected your data set, and from that data set you finally concluded no standard of living has been increased in Delhi, let's say past few months, something like that. Okay, so here bias is there, right? So correct. So you I mean what you can say, bias means you collected the data from only from rich locality. You didn't collect the data from random pattern, right? From poor locality also, or something like that, right? Are you getting my point? Okay.
Yes, sir.
So there are lots of things. Those things we are not studying here actually. But if you are interested, I can suggest you book which is very good one. Okay?
Sure, sir.
Okay.
One thing more, sir. Suppose we have to use data set for machine learning. So won't it be a nice thing that we will first convert the given data on the basis of this sampling and then proceed with the modeling part?
No, sampling is something. See, the method which I told you, right? This is something to collect the data. I mean, these are the methods to collect the data. Suppose, see, you don't have, I mean, available data. For example, okay. Suppose suppose you are going to, Kaggle and all. So if you go there, you will find lots of data, right? Available data already, right? You can perform your analysis, whatever analysis you want. Let's say you want to perform linear regression based on house pricing or whatever, something like that, right? But these methods are just to collect the data. So lots of government policy and all. I mean, they are doing survey and all. So those are based on how to collect these kind of data. Like it will depend on the what's your objective of the survey.
So, sir, suppose that I am using secondary data for yield prediction, and there is lots of live data whose sample is available for say half hourly basis or hourly basis on the internet. It is also collected by some mechanism. Somehow, some mechanism is there to collect these data and record and publish them. So if we are using that kind of data, on that kind of data also we can do this kind of sampling before feeding it to directly to our model by cleaning and all those thing only to make it more robust. Isn't it possible?
No. What do you mean by using this sampling? You want?
See, sir, as far as I know that without following the IIT norm, if we are going to use any kind of data and we are going to use any of this model for our analysis purpose, then biasness is going to be there in that particular model. So to escape that kind of biasness, I'm thinking that if we use this kind of method to ensure that it is that the data that I am using to feed these models is strictly following the IIT norms.
We are preferring to go with the IIT samples actually.
Yes, sir.
Yeah, so it's a preferable choice. So actually, so thing is that based on bias, human error, and all, right? So maybe you can see whenever we are going to find the we are going to make final conclusion and all. So we are okay with some sort of error, right? 5% error or 10% of error. Like we are okay with this kind of error something. So that's depend thing, but I'm not sure the thing which you are saying this we can inbuild. As per my knowledge, these are the methods to collect the different kind of sample.
Yes, suppose
ML
sir,
model.
we are going to collect data from some IoT device.
Which device?
IoT device.
Okay.
So that data is purely random.
Okay.
So shouldn't we ensure that that data that has been fetched by the IoT device is following IIT norms?
IIT norms, I think we need to check, right?
Yeah.
Before checking, I don't think we can say something.
Okay.
Actually, at the end, whatever the distribution or sample you are collecting, right? So there are some kind of assumptions, right? So your samples should be random and independent. Your samples, let's say the samples from where you are collecting, right? That population should be normally distributed, something like that. Okay. If though that population is not normally distributed, we have to go with other approaches, other analysis part of
Even we
some.
can go for some statistical based thing to make it normal.
Correct.
Which
So
is a
thing is
normal
that
practice.
thing is that there are lots of approach. Maybe you heard about t-test and all, chi-square test, and also those are different kind of method to apply in different scenario. Okay. So that we can discuss it later, right? I think we can.
Okay. Thank you very much.
Yeah. Okay. Yeah. Okay. So this binomial distribution and is nothing but, so whenever you are going to perform an IIT Bernoulli trials, okay, and IIT Bernoulli trials, okay, then it will form binomial distribution. Okay, so I will explain. For example, if you are going to toss a coin, okay, so a single time, this is the Bernoulli experiment. Either you will get head or tail. Yes or no? This is Bernoulli experiment, right?
Yes.
If I'm going to toss a coin thrice, okay. So first of all, if you are going to toss a coin 3 times, so this is the okay. So let's make it. Let me define like this. Suppose x1 is the outcome when you are going to toss a coin first time. So this will give you 2 outcomes, right? Head, tail? Yes or no? If let me define x2 as a outcome at the second trial. X3 let's define as the outcome at the third trial. So first of all, each xi individually will follow Bernoulli experiment. Yes, no?
Yes.
Yes or no? Correct?
Yes, sir.
So if I will, I will take all these three together. That means if I will say x1 plus x2 plus x3, okay, let me say this x, let me define x as a x1 plus x2 plus x3. This will follow binomial distribution with parameter. So this is 3, comma, let's say success probability is half. So this is the notation. X will follow binomial distribution with parameter n, comma p. What is this n? This is number of trials. And what is this p? This p is success probability
of success.
So here you can relate how many trials we are doing? 3. Yes or no? And what is the success probability? Half. Right? I'm assuming for now my coin is unbiased. So far so good. Any doubt? Yes or no?
No.
I mean, no doubt or no clear?
No doubt.
No any doubt,
No
sir.
doubt. Okay, great. Okay, fine. So actually, okay, can you tell me what this X will represent basically?
Expected outcome, expected probability, total.
No, I'm talking about how will you define your X here by seeing this one?
Number of trials.
Number of success
Number
in
of
3
hits?
trials.
We are yeah, correct. So it's an X will represent basically number of success in
3 trials.
N trials. Your
Okay.
N independent Bernoulli trials, right? Okay. Let me take one example. That will give you a clear idea. Okay. Instead of N, let's start very basic thing. Suppose N I have 3. I have 3 independent Bernoulli trials. Okay. Let's say I'm saying like this. Okay. So what will be the outcomes? Can you tell me? So outcome will be, let's say if you are performing Bernoulli trials, in Bernoulli trials, I will get either success, either failure, right? So it is possible I will get all success, yes or no?
8 possibility.
8 possibility, right? Everyone getting this? I will get, suppose this is x1, this is x2, this is x3. At the first trial, I can get S. At the second trial, I can get success. At the third trial, I can get success. Yes or no?
Yes, sir.
Everyone is getting this part, right?
Yes,
Yes, sir.
Okay. So what will be the second probability? Success, failure.
Failure. Yes, sir.
Right? Success, failure, success.
Yeah.
Success, failure.
At the
Yes or
end,
no?
failure.
Right?
Yes.
Then failure, success. Right? Then F, S, F. Just tell me whether shouldn't be repeated. F, S, and all failure. Correct? It's fine for everyone. Right?
Yeah.
Total 8, right?
Yes, sir.
3, 3, 6, 2, 8. Yeah. Now tell me what will be the probability for this success? P.
1 by.
No, I'm just talking in general. Suppose success probability is P, then P into P.
PQ.
Since all trials are independent, right? What about this part? P into P into
1 minus P.
1 minus P. What about this part? P
Into
into
P.
1 minus P into P. What about this part? P into
1 minus
1
P
minus
into 1
P
minus
into 1 minus P. And what about this part? 1 minus P into P to P. And then 1 minus P into 1 minus P. And 1 minus P into 1 minus P into P. And then 1 minus P into 1 minus P into 1 minus P. So you can focus here. Actually, what X represents number of success, in what will be your X basically? Number of success in all these three trials, yes or no?
Yes,
right?
sir.
So how many success is here? 3?
Yes.
See, 1, 2, 3. How many success here?
2.
2,
2.
2,
1.
1,
2.
2, 1,
1.
1 and
0.
0. So what is the possible values your X is taking here?
0, 1, 2, 3.
Correct. X is taking 0, 1, 2, 3. Means if you see logically, X represent the number of success in your trial. Here, how many trials you are doing? 3 trials. So in those 3 trials, X will take. You will get 0 success. You can get 1 success. You can get 2 success. You can get 3 success. So far, so good.
Yes, sir.
Now tell me, what is the probability? What will the probability? What will the probability for 0? 1 minus p raised power q.
Yes, sir.
And what is the probability for 1? Means p into 1 minus p square. So 1, 2, 3 times, right? Are you getting? So 3 times p into 1 minus p square. See, we have to add. See, 1 will be in this case, or in this case, or in this case. So we have to add all these 3 probability. Correct or not?
Yes, sir.
What
Yes,
about x equal to 2? This
times.
probability.
It will be
This
p
probability.
square into 1 minus p into
Correct. So this is
3 times.
3 into p square into 1 minus p. And for 3 it's p cube, right? Only one part, right? Now you can focus here. Actually, now we'll think similarly. Can we extend for n trials, right?
Yes, sir.
Actually, okay. So this, if you focus here a little bit carefully. So can I write probability x equal to? So this is for 0, right?
3c0.
Okay. So for 0, I got 1 minus p raised power q. Then for probability x equal to 1, we have 3 into p into 1 minus p raised power 2. Then probability x equal to 2, we had 3p square 1 minus p, and probability x equal to 3, we have p cube. Okay. So this was for 3 trials. Okay. What if you have n trials?
Just like binomial.
Number of possible success will be 0 to 1. 0, 1, 2.
Yeah. So let's think in general. So now you will be able to relate actually. So suppose you are doing an independent Bernoulli trials. Suppose I'm interested. I got out of X represents how what number of success, right?
In entrance.
In an independent trials. So what if suppose for I success? Suppose I got I success. So here what you are getting? 1 success, 2 failure, right?
Yes, sir.
Here 2 success, 1 failure, all success, right? So can you tell me, if you have I success, then what will be the number of failures? N minus I? Yes or no? So here you are doing 3
Yes.
trials, 1 success, remaining 2 failure. Yes or no?
Yes, sir.
Correct? Are you getting?
Yes, sir.
Yes, sir.
So there is one. What about this part? From where these 3 came?
So 3 choose 1, 3 choose 2, and 3 choose 1.
3 choose 2, 3 choose 1, right? That means what? Can I say I'm getting, I success and n minus I failures? Yes or no?
Yes, sir.
Yes.
Like number of, I can say. Okay, first of all, okay, let me write number of different, basically number of different outcomes that results in I success and n minus I failures. In how many ways I can get this part?
And choose 1.
And choose I. Yes, sir.
NCI.
NCI, right? Out of this NCI, okay, so I can say probability. Okay, now you will give me the answer. Probability of I success, okay, in n trials. It will be probability of x equal to I. So first of all, suppose you are getting I success. That means P raised for I.
And Q 1 minus
Right?
P raised to
1 minus P raised for remaining
N
n
minus
minus I as a failure, right? And
Yes.
for
Yes.
this,
Yes.
n
And
choose
choose I.
yes or no. Now what will be the limit for I? I will
N.
be
N.
0 to
0 to n.
Yeah.
any doubt till now? Yes, no? Is this clear so far?
Yes, sir.
Yes, sir.
Yes,
So
sir.
basically,
Yes,
this is
sir.
probability mass function for your binomial distribution. So what is the expectation of your binomial distribution and what is the variance of your binomial distribution? Actually, you can do with this part, okay? But it's a little bit bit lengthy procedure to do this summation of x into px, something like that. So we can apply the concept. So what is the concept? Like n independent Bernoulli trials will give you what? Binomial? Yes or no?
Yes, sir.
Correct? Now, if n independent Bernoulli trials means what? X1 plus, suppose x is x1 plus x2 plus x3 plus so on, xn. This will be your binomial with parameter n comma p.
Yes,
Yes
sir.
or no? This is the
Yes, sir.
independent Bernoulli trials, right? And we have seen what is the expectation of your Bernoulli random variable. Very well. Yeah, for a single Bernoulli expectation is P. Variance is P into 1 minus P.
1 minus. Yes.
Okay. So if you will apply the property of expectation, so what will the expectation of x here?
And
So
into P.
expectation of x1 plus x2 plus so on xn, right?
Yes.
Now it will become expectation of x1 plus expectation of x2 plus so on expectation of x of n. Yes or no? And
Yes,
these
sir.
all each xi is here. Each xi is Bernoulli, right?
Yes, sir.
So what is the expectation of a Bernoulli random variable? It's p plus so on p, and it will be n into
P.
So this is the expectation of a binomial distribution. Okay.
Yes, sir.
Is it clear?
Yes, sir.
Okay. Clear to all of you? And what is the variance
sir.
of x? So
And-
variance of it will be x1 plus x2 plus so on xn, right? And we know all are IID, right? All are independent. And
Yes, sir.
you have seen, okay. First of all, tell me what is the variance of x1 plus x2? Suppose you do not have any information about independence of x1 and x2. How will you write?
Variance of x1 plus variance of x2 minus covariance of x1, x2.
Minus or plus?
Plus, I think.
Plus
Sorry.
2 times of covariance of x1
Plus
and
twice of covariance, sir.
correct.
Sorry.
So when we are saying x1 and x2 are independent, this covariance term will be 0.
0.
So covariance represents actually linear association between two random variables. So in that case, you will get variance of x1 plus x2 is equal to variance of x1 plus variance of x2. Since we know all xi are independent Bernoulli trials. So if all are independent, then I can write as variance of x1 plus variance of x2. I can write this one as a variance of x1 plus variance of x2.
Sir,
plus
sigma
so
v
on.
of x equal to I, sir.
Sorry?
Sir, we can write as sigma I equal to 1 to n v of
Yeah,
xi, sir.
that I can write. That's no problem. Yeah, that's okay.
Yes,
So
sir.
what is the variance of each xi in case of Bernoulli?
N into P into 1 minus P.
No, not n into p into 1 minus p.
Sorry, sir.
P into 1 minus p plus for x2 again p into 1 minus p and so on up to p into 1 minus p. So variance of your binomial random variable will be n into p into 1 minus p.
Yes, sir.
Okay. So you can keep this in your mind. Is this clear? Any doubt?
Yeah, sir. Simplicity n add हो रहा है दोनों expectation and variance.
Correct.
इसके बाद
Correct. Any doubt?
No, sir.
Fine. Okay. So let me take one example. Let's see whether you are able to. Okay. Any doubt? So far it's clear idea behind binomial distribution. Yes. Okay. Okay. So if this is okay, so let me take one example. Everyone have pen and paper?
Yes.
Okay. Suppose I'm saying 10 coins are thrown let's say simultaneously, and let's say I'm saying what is the probability of getting let's say at least what is the probability of getting 7 heads. Okay. There is some okay, great. So if you see, let me do this one. I will give you another example. So what is the, first of all, we are going to toss a coin here, right? Okay. So if you see, what is the P? I mean, success probability?
Half.
Half, right? Because I'm interested in getting ahead, right? So this is probability of getting ahead. This is will be half. What is the probability of 1 minus P?
Half.
Again,
Half.
half.
Okay, what is the N here? Value of N?
10.
10, because we are tossing the coin 10 times, right? So what will the probability that you will get 7 head? First of all, what will the probability X will be? You will get X.
10
Okay,
choose.
let's talk about in terms of 7. So you will get 7 head. That means what? This P into P into P into how many times?
7 times.
7
7
times.
times.
That means remaining 3 times you are getting
1
failure,
minus.
right?
Yes.
And
Yeah.
this 10
10
choose.
C7.
Okay. So basically, here you can write 10 C7 P raised power 7 1 minus P raised power 3. Yes or no? And this
Yes,
P
sir.
is nothing but your half actually. Okay.
Yes.
So in general, probability of getting a small x success is nothing but NCX P raised power x 1 minus P raised power n minus x. This is the PMF of your binomial distribution. Is this clear? Here you have to just substitute the value of P as a half. You will get the final answer. Is this fine or not?
Yes, sir. Yes.
Now tell me if my question is probability of getting at least 7 hits. Then how will you proceed? I mean, how should I write first of all in mathematical notation meaning of this 7 hit?
0 head, 1 head, 2 head, 3 head.
7, 8, 9, 10.
Oh, sorry.
Correct, right? So
Yes.
because I'm talking at least 7, so it should be x should be more greater or
More
equal
than
to 7,
7.
right? So I'm
Yes,
talking about probability x equal to 7 plus probability x equal to 8 plus probability x equal to 9 plus probability x equal to 10, because we have maximum 10 uh, uh, this part, right? Yeah. Is this fine? Any doubt? Yes, no?
Yes. No, sir.
Okay, so
No, sir.
I'm based on this concept, I will give you one question. Let's try to no. I mean, just first of all, you just try on your own, and then we'll see whether you are getting on. Okay. So suppose I'm saying the probability of, let's say, of a player. Okay. Suppose probability of let's say hitting target, let's say is 1/4, for example. So let me create one. Suppose, let's say I'm saying if he fires, no, let's say 7 times. Okay, then what is the probability that, or let's say probability of his hitting the target at least, let's say, twice. Okay. So first of all, just read the question carefully and tell me whether are you able to identify this is the binomial or not.
It is.
It's a binomial, right? Because he
Hits
fires
or
how
not
many
hit?
times? He
Hits or
fires, correct. Whether he will
7 times.
he will hit the target or not. Only two possibility, right? If he will hit the target, that is the probability 1/4, and if he is failed to hit the target, it will be 3/4, right?
3/4.
And
Yes,
we
sir.
are doing the same independent trials how many times? 7 times, right? So
7.
that will form a binomial. Okay, what will the parameter here? It will be binomial 7 comma 1/4. Yes or no? This is your and this is your success probability, right? Now by using this thing, can you tell me the, or just I don't need the final answer. Just tell me how will you
add
can
2,
take
3, 4, 5, 6, 7.
No, no, no. I think we
Rather
should
than that,
start
we can
at
also
0,
do
1, 2.
1 minus
Yeah.
Yeah, minus 0, 1, 2, whatever.
minus 0, 1, 2 or minus
0 and 1.
0
minus
and 1, right?
0 and 1.
Okay, first let's talk about in general. What will be the probability of getting X success or X target out of 7? How should I write?
7cx.
7cx.
Yes.
1
Correct.
by 4 to the power x.
Very good. And
3
1
by
minus 1/4 is for 7 minus
7
x.
7
And
minus
this
x.
small x value can take 0, 1 up to
7.
7. Right?
7.
So far so good. Now, I'm talking about probability x greater than or equal to 2. Right? So you can go with this. That's not a problem. But thing is that it will be a bit complicated, right? It will take some time to calculate, right? So a better approach is I can write this as a 1 minus probability x less than 2. So less than 2 means what? 1 minus, I can say probability x will take 0 plus probability x will be 1.
1.
Correct?
Yeah.
Yes.
Right? And what will be the, how will you write probability x equal to 0? It will be 7c0, 1/4 is power 0,
0.
3/4 is
And
power 7
yes, sir.
plus 7c1,
7c1.
1/4 is
1 by
power
4 raised to power 1. And
3/4 is
3
power
by
7.
4 raised to 6.
Yeah.
Yeah.
Whatever the final, even I don't know the final answer for this question, but if you calculate, you will get the answer. Okay. Let me take a different thing. Suppose let's change a bit more about this part. Okay, change means I will ask less at most. Okay, suppose what is the probability that he will hit the target in at most 3 trials? Then I will write x less or equal to 3, right? At most 3 means it can't exceed 3. Yes or no? So in this case, I have to add probability x equal to 0 plus
0
probability x equal to 1 plus probability x equal to 2 plus
and
probability x
3.
equal to 3. Right? So far so good?
Yes. Yes, sir.
Okay. One homework for to all of you. No homework, or you can, if you're able to give me answer right now. Suppose I'm saying expectation of x is np and variance of x is n into p into 1 minus p. Okay. Suppose I'm going to make a statement and tell me whether my statement is correct or not. Okay. So my statement is suppose I'm saying the mean of binomial distribution is 3 and variance is 4. Tell me whether this statement is correct or no. If so, then why? If not, then why not?
So we can equate this to n into p is equal to 3. Hello?
Incorrect.
Yeah, I'm not asking any value. Just tell me whether the statement which I given, written here, whether this is correct or not.
The probability is coming out to be negative, sir. So I don't think it should be correct.
I think
Yeah. I'm also getting
Incorrect
negative.
option.
Okay. Any other way?
So n into p is 3. When multiply 1 minus something less than 1, then always
Correct. Actually,
less than 3.
you can think a bit here. Actually, so this n p into 1 minus p. Okay. All of those who give the answer is correct. Actually, this will be less than n into p always. I will give you the reason because this p will always be in between 0 and 1. Would you agree with me?
Yes, sir.
See,
Probably.
or else you can say this 1 minus p, because see this part is same, right? And
Yes.
this part is what? 1 minus p, right?
Yeah, probably.
Correct. So this and we know 1 minus p will always be in between 0 and 1.
Yes, sir.
Correct. So that's why this variance will always be less than mean. And I told, I gave mean is greater than, mean is less than variance.
Got it, sir.
Got it?
Yeah.
Yes, sir.
Right?
Yes.
So, okay, so far you got, it's clear to everyone?
Yes,
Yes,
sir.
sir.
Okay, so let me take one more example and then I will move to the next distribution. Or if this is clear, then can I proceed with the next distribution?
give examples.
Okay. Okay, so most probably, let me take another example. What it can be? Okay, let me. Okay, so take one example from lectures. If we are not able to recall, I can change in. I don't want to take the questions, related with the coin and die only. So it should be in 11.4. Yeah, there are some questions related to this. I will explain from there itself. Okay, maybe that will be. Or should I explain with the activity? Let's go with the activity, right? That will be fine.
Yeah. Go.
It's already given in this form. Okay. Let me see here. Yeah, let's how many of you tried this question number 5? Yeah. Anyone?
Yeah. I tried.
Did you get the correct answer? No? Anyone?
No, Ji.
I tried, but got stuck in the middle.
Okay, no worry, no worry. So we'll see. We'll try to see. It's a bit okay. So what is the question? Suppose that 4.5% of people living in a particular city own a Creta, right? So by this statement, what's the, you can guess? So this is the success probability. Means ownership of a Creta or owning a Creta is a success probability, right? So P is what? 4.5%. Yes or no? So
Yes.
P is 4.5%. That means 0.045, right?
0.045.
And they will not own a Creta. It will be 1 minus 0.045. Okay. Now, a survey has been conducted to know what brands of cars people use in the city. What is the probability that the 12th person being interviewed during the survey is the second one who own a Creta? Okay, before going to this, okay, what do you mean by this? Okay, first of all, tell me, what did you mean by this statement? 12th person being interviewed during the survey is the second one who own a Creta.
Before 12%, there is one more person who owns
Yeah,
a
there is
Creta.
only one person before 12 who owns a Creta.
So in 1 to 12, there are only 2 people who own the Creta.
Correct. So can I say the 12th person who is interviewed, he is the second one, right?
Yes, sir.
This is the second person, right? That means what? The first person, first one is from out of 11?
Yes, sir.
Yeah,
Yes or
1
no?
to 11.
Correct? Would you
Yes,
agree
sir.
with me now? So
Yes, sir.
question is not about, you
Yes.
know, the both people are from out of 12. No, I'm
It's out of
saying
11.
out of 11. One is out
Yeah.
of 11, and for sure, second one is the which
12th
12th person, right?
Yes.
So
12%.
for this, I can apply binomial distribution
Yes, sir.
because out of 11, one is going to
Own a Creta.
own a Creta. What is the
Yes.
probability for this? 0.0445 raised
0.045.
power 1.
1.
1 minus 0.045 raised power 11
10.
minus 1, which is 10.
10.
And for this probability,
1.
it will be 0. No, not 1. Owning a Creta is a 0.045, right?
But we are okay.
No. So probability that owning a Creta, it's a 0.045. Okay.
Acha, yeah, it's fixed now because he is owning. Yeah, got
Correct.
it.
So you can think
That's
this
where
as
I
a
got stuck.
correct. So this is the two things. So if suppose question is out of 12, 2 of them own a Creta, then it will be 12C2, 0.045 raised power 2, and 1 minus 0.04 raised power 12 minus 2, which is 10. So these two are the different scenario. Is this clear now? Yes?
Yes,
No?
clear.
Yeah. Okay. Yeah. Correct.
What is the question to the last solution?
This part?
Yeah, the last one.
Yeah, you can frame now, right?
0.04 multiplied and answer that one. Can you explain again?
Sorry, your voice was some.
Yes, sir. Actually, that zero last solution, na 0.045 multiplied with the last.
This one. This part you are talking. See, what is the question? Question says 12th person.
Yes.
12th person being interviewed, he own a Creta, right? He is the second one who is own a Creta. And what is the probability for owning a Creta? 0.045. Okay. So for this, we know 12th person. For the second person, this is the you can say probability, right? Fixed probability, 0.045. And the first people, we don't know, it will be out of 11 only, right? So for this, I can apply the binomial distribution. Okay.
So to me, it felt that the 12% is fixed, so the probability should be 1. That's why I said 1.
No, it's not 1. It's not like he is fixed. So, okay, tell me. So he is fixed for what? Like we know
I got your
he.
point, sir.
Yeah. Okay, it's the second one who owns
Yes.
it. And for this point, I think you asked the what is the statement. It will be what is the probability that out of 12 person, 2 of them
Owns a Creta.
own a Creta, right?
In
Is
that
this clear now?
The 12% should probably should be multiplied.
Yeah. That's why I multiplied here. Okay. It's a
should be-
multiplication. Yeah, it's a multiplication. Okay. Yeah. So next is called. We'll move to the called hypergeometric distribution.
Sir. Sir.
Yeah.
So when you say in Bernoulli the parameter is p and in binomial the parameter is n comma p, what exactly we are trying to say?
No. See, in Bernoulli, we are like dealing with only one trial, right? Bernoulli
Correct, sir.
trial, right? Single
Correct,
trial.
sir.
in binomial, if I'm writing binomial n comma p, so
Yes.
we are dealing with n Bernoulli trials, right?
Correct, sir. Correct,
We
sir.
have number of n is number of independent trials and p is the success probability.
Correct, sir.
Okay? And each, suppose you have n independent Bernoulli trials, each xi will constant will make combined it. I mean, if you
Yes,
combine
yes.
all these xi, it will give you the
Yes, sir. So my question is there any significance of knowing the parameters?
yes, that's what, right? So then if you don't know this n and p, how will you find the any probability and all of? If suppose I have asked what is the expectation of x, expectation of x is n into p, you can directly calculate, right? If you know the parameters. The parameters are something which will define your scenario. Okay, suppose you don't know n, then that means you don't know how many times you are doing your trials, right? Or you are doing your experiment. Agree?
I mean to say that it's just a notation that we want to know.
Correct. Yeah, correct.
Okay,
Just a
okay.
notation. If you okay, suppose someone is written x follow b n comma p, that means x is following binomial with parameter n and p, where n is number of trials and p is successful. So it's a understood procedure actually.
Okay.
When
Prashant, I have one more question.
yeah.
So you have written xn is equal to x1 plus x2 plus x3 up to xn, correct?
No, it's a x actually. Sorry. Yeah.
Okay, sorry. Okay,
Yeah,
x equal to x1 plus
yeah,
x2.
yeah,
So x is the binomial distribution, x1, x2, xn are Bernoulli trials.
Correct. Yeah.
What is the intuition of having plus here? Like, why can't it be multiplication?
No, plus means all each xi. See, suppose I took one example. Okay. Suppose I will suppose I'm going to toss a coin one time. Okay. Either I will get head, I will get tail, right? This is success, this is failure, right?
Correct.
If I will toss coin second times, head tail, success, failure. Third time, head tail, success, failure, right?
Failure. Yeah.
So if I will ask what is the number of success you will get in all these three tries, then how will you proceed?
Okay, you're adding there. Okay.
Correct.
Got it.
So all this in general we are saying an independent Bernoulli trials will give you the binomial. Okay. Correct.
Yeah, basically you're doing P of x1 intersection x2 intersection x3. Since they are independent, I'm getting P1 plus P2 plus P3.
Is it in intersection or union?
Union. We are adding, right? We are
union.
adding. Intersection will be multiplication. So now let's see the hypergeometric scenario. Actually, from where this came, we'll see one. I will explain with one of the example. So in binomial distribution, what was the case? Trials was independent, right? Yes or no?
Yes,
and
sir,
success
identical
probability was same, right? Yes or no? These were the two main case for binomial distribution.
Yes, sir.
Yes. Okay. Now, suppose I'm saying your trials are not independent. Then we must have something different thing, right? Your trials are not independent and the probability of success, probability of success is not the same for all trials. Okay. So these two cases or conditions were fulfilled in case of binomial distribution, right? Trials were independent and success probability that was P was same throughout the trials. Yes or no? If you're going to toss a coin one times, you will get, let's say you unbiased coin, probability of success is half, right? If you toss second times, again success probability is half. Third times half, right? Yes or no?
Yes, sir.
Right? So what if in this case, let's say we have something 4 white and 3 black ball, for example. Okay. And we have draw one black ball and one white ball, for example. So what is the probability of drawing a black ball?
3/7.
3/7. Right? Probability of drawing a white ball?
4/7.
Now, suppose I'm going to drawing this ball without replacement. Okay. So if you are drawing without replacement and suppose you have drawn one black ball, that means what? How many balls remaining here?
6 more.
4 white and 2 black.
Yes.
If you have drawn one white, then 3 white, 3 black, right? Would you agree with me?
Yes.
Correct. So in this scenario, suppose you have drawn again one black ball, okay? Then and one white ball. What is the probability that you will draw one black ball?
2 by 6.
2 by 6?
1.
No, no one, right? And white ball?
4 by 6.
4 by 6. And in this case, drawing a black ball?
3 by 6.
Drawing a white ball?
3 by 6.
3 by 6.
Right? Now you will be having here 4 white and 1 black. And here?
3 white, 1, 2 black.
Black, right? And here? 3 white, 2 black. And here?
2 white, 3 black.
2 white, 3 black. So can you tell me, first of all, we are doing without replacement, right? So can you tell me trials are dependent or independent?
Dependent, sir.
Dependent, right? And what is the success probability here? Is it same or is it changing?
Changing, sir.
Change, sir.
Correct. So in this kind of scenario, binomial distribution fail actually. Okay. So when hypergeometric distribution come, I will take one example. Then I will move to the assumptions of your basic hypergeometric distribution. So suppose how we can proceed with that. You will tell me without knowing the hypergeometric distribution. Suppose you have a box. Okay. In that box, you have total capital. Let me use some different color. Suppose in that box, you have total capital N balls. Out of which, suppose I'm saying M are red. Okay. Then let's say, how many ball then will be blue if M are red?
N minus
N minus
N
M.
minus n.
Capital N minus M will be blue, right? Suppose I'm saying you are going to draw a sample of small n size, okay, without replacement. Okay. So far, so good? Yes, no?
Yes.
Yeah, correct. So suppose I'm saying out of this, suppose a small, look, okay, suppose X represents the number of red balls drawn in the selected sample. Okay. And suppose I have question is, what is the probability that I ball you have drawn I red ball? So first of all, what will be the total case?
N.
NCM.
No, I'm talking about total case.
Capital N, CN.
Capital N, C, small n.
Yeah.
Right?
Yeah.
Yeah, this is the total case, right? This is the total n small balls we are drawing randomly without replacement, right?
Yeah.
Correct or not?
Yeah.
Right? And what is the probability for what will be your favorable cases? I red ball, that means it will be
MCI.
M choose I, yes or no?
Yeah.
Yes.
And remaining will be blue.
Yeah.
N minus M.
Yeah, so it will be N minus M choose small n minus I. Would you agree with me or not?
Yes.
Yes.
Right?
Yes.
Clear? So this is the hypergeometric distribution actually. So what's the case in hypergeometric distribution? What are the case? Now maybe this should be clear with this example. Let me know if it is not clear. So when you will say your random variable X is hypergeometric distribution. So when I will say my random variable X is hypergeometric distribution. Can I say when I have a fixed number of trials? Yes or no?
Yes.
Here you have fixed number of trials, right? And when the probability of success, is not same for all trials. Yes or no?
Yes, sir.
Yes.
Actually, when you can use, so basically I can say I will use hypergeometric distribution when my population, okay, is divided into, by this case I can say my population means I have capital N balls. So my population is divided into two groups, right? Let's write like this, two and only two independent subset actually, or you can say, or groups you can say, that's not a problem. So here you had two groups, right? One for black and another for red and blue, right?
Yes.
Okay. So in this scenario, you can go with the hypergeometric distribution when you do not, I mean, your trials are not independent and success probability is not same for all trials. Is it clear? Do you want
Yes.
to write me the formal definition, or is it okay if we can
Prashant,
proceed?
can you explain the last requirement, the third
Which
one?
one?
Population is divided.
Yeah,
That
means like whenever your population is divided into two and only two independent subset, means here I have population of capital N balls, right? This population was divided into two groups only. This group of red ball, a group of blue ball. Okay.
suppose I had a set of white balls in this.
Huh?
Still, I can write it as MCI.
No. In hypergeometric, you should have only two groups actually.
No, but then that group could also be the three color balls because if our success criteria is only getting red balls, so it's red versus non-red.
Yeah, red versus non-red. If you want to three groups, then this will be divided, right? Again, let's say you have a small m, m1 blue, and then capital N minus small m minus small m1 will be some other color ball, right?
It would be n minus m only because one is your success criteria is red, and whatever colors of groups are is the other group.
Yeah, other group. That's why I'm saying only two groups should be there. It's not like it should be blue only. It can be either way.
Yeah.
Okay.
So
It can be.
the point is trying to say is even if there are 100 colors ball,
Mhm.
but if you are choosing only one color, then all the remaining color can be considered as one group, which is red, right? And then
Okay. If that is the case, I think we can go. But we have to go with only two types of. I mean,
because
basically,
it is
what
whether
is
you
the
call it
case?
blue or not, but you are doing it
Huh.
n minus one only, right? So all
Yeah.
remaining other than
You are saying that is a other category. Then I mean, you are considering as a failure. That's okay then. Basically, it should be m of the item should be one type, okay, which is you are going to consider as a success,
And n
and
minus m
remaining
will be others.
other type, yeah, second type, or you can say.
Yeah, got it.
Okay, fine. Okay. Yeah. So let me take one example. Suppose you will tell, I mean, for this I think there is no need to remember the PMF. If you remember the PMF and all, if you PMF is in your mind, that's good actually. Okay, so tell me, suppose I'm saying a bag, in a bag there are 7 balls, okay, out of which, suppose I'm saying 4 are white and 3 are black. There is some background noise. Okay, so question is, suppose randomly I'm going to do a select a sample of 2 balls without sample, sorry, without replacement. So what will be my value of small n? It will be 2, right?
Yes.
And suppose I'm saying my x is, I mean, I'm interested in the number of black balls selected. Okay, so this means what? This is your small m, right? And this is your n minus m. Yes or no? Right? So what is the probability that, tell me, 0 black ball will be selected? First of all, let's talk about in general. Suppose I black ball is selected. Then what should I write? No, it's in total we are select. Yeah, I ball. So what will be the total case?
7C2.
7C2. For numerator part, 3 choose I, right? And remaining will be from
4,
4,
2 minus
right?
I.
2 minus I. Okay. So if I will ask what is the probability x equal to 0, you have to just simply substitute the value of I, right? Replace the value of, okay. So something like that we can proceed with, this hypergeometric case. Okay, tell me what will be the value of, I mean, range of I or range of x. Range means what is the possible values your x can take?
Definitely less than 1 because you're divided.
Maximum 2 because n is 2. Oh, sorry, I can be 0 to 2. Sorry.
0 to
2.
0, 1, 2.
Okay. 0 to 2. Okay, let me
But why
check.
2 balls? Considering you're doing 2 balls.
Sorry?
So when we say 3C0, it will become 4C2, no? So
Sir, I will be 0, 1, 2 only, because if you can simply if you put 3, for example, and you can't, first of all, because in total we are drawing 2 only.
yes.
Okay. So okay, let me take another one. Maybe that will give you a more no, idea about this. Let's say what we can say. I want to take one example which should, this contradict of this part. Anyone can think a bit for this?
I mean, what if we
Which
want
one?
to calculate? Can you show me the ball numbers, please? Scroll up, please.
Yeah, 7
What
and
what if we have 4 drawns and then we are saying getting 3 black balls?
getting 3 black balls.
Out of 4 draws.
Okay. Yeah, in that case, what will the value of I?
0 to 4.
0 to 3.
0 to 3, right? You can't say
3,
4.
okay, wait.
Yeah, that's correct. Suppose you are drawn
0 to
4, right? So don't think it will be, this will be the maximum one, okay? You should say n equal to 4. The probability of x equal to y will be, in total, it will be 7, choose 4. The 3ci, 4, 4 minus I, right? So here I will be 0, 1 up to 3 only, right?
Okay.
Not 4. Because I is the maximum, right? Maximum 3 ball you can draw. Yes or no? So actually, thing is that in general, there are limits for this. Okay. What is that limit? I will write. So suppose out of n things, m are one kind. Okay. And capital N minus m are second kind, right? So suppose x represents, number of your that success you can say. So what will the probability x equal to x? It should be first of all, total will be n choose n, because I'm going to draw small n things without replacement, and it will be mcx and capital N minus m c small n minus x, right? So there are limits. You can cross check with some different example. Your x should be first of all less than n. Yes or no? You can cross check with there. So here n is, we are drawing total 4 balls, right? And this x means I'm talking about I. So this is less than or equal to 4. It can't exceed. Yes or no?
Yes.
Yeah.
X should be less than or equal to m also. M is the number of ball which you are draw like M is like your success thing. So here, what is the success? 3 black ball, right? So this x, this I will always be less than or equal to 3, right? It can't take 4. Yes or no?
Yeah, I mean, for simplicity, you can
Yes,
write
of course.
Right?
small
Yeah.
xm. You can write P probability of capital X is equal to xm. Let's say just for some.
Yeah. And this small n minus m will be greater than or equal to small n minus x. You can cross check with some examples. Okay. Now, so this is the limits. Actually, generally people make mistake. They think we are drawing 4 balls, so they will write I equal to 0, 1, 2, 3 and 4. So that's not the correct thing. You can cross check with here itself. Okay. And with this part. How many balls you have to draw accordingly. Okay. Is this fine? Some sort of idea is okay to all of you?
Yes.
Okay. Okay, fine. So let's move to the expectation part, expectation of your hypergeometric distribution. So we have seen one. I will write the formula actually directly. I'm not going in the derivation part because we have to cover the Poisson also. So here we have total capital N out of M are one kind, capital N minus M are second kind, and we are drawing N things randomly without replacement. So what is the expectation of your hypergeometric distribution is nothing but small m into small n divided by capital N. Okay, this is the expectation of hypergeometric distribution. So you can directly calculate this value. Okay, I'm not going into the derivation part, that will take a bit time. So I will write the variance formula also. What is the variance? I will verify one more thing from that. So variance is n into small m divided by capital N and capital N minus m divided by capital N and capital N minus small n divided by capital N minus 1. So from here, one thing it will be clear in a minute. So can you focus a bit here? What is the it will be clear. Okay, suppose this is the case in case of hypergeometric. Okay, suppose I'm saying I have a random variable, let's say x1 or let's say z, for example. It is binomial random variable with parameter n, and let's say success probability is m by n. This is possible or not, right? So what will be this expectation of x here in case of by using this, not x, expectation of z, n into p,
N into N, M by
right? So here it
N.
will be n into m by n.
Yes.
Yes or no? And what will be the variance of z?
N into
n
M by
into
N
m by n
into
into
1
1
minus
minus m by
M by
n.
N. Yes.
Now from here, can I write n into
Okay.
m by n into n minus m divided by n? So far, so
Yes.
good.
Yes, sir.
So what is
Yes,
the
sir.
extra? This is the extra,
Yes.
right? So actually, this is something known as finite population correction. Don't worry, I will explain with example. So we have this term, right? N minus n divided by capital N minus 1. So what if I will take small n is equal to 1? Then what you will get?
1.
Small n is equal to 1 means what? Small n is equal to 1 means what? Just tell me. N is equal to 1 means what?
1.
You are drawing, you are doing only one thing, right?
Yes.
That means you are doing Bernoulli experiment. Either you will draw red ball or blue ball. That's all. If n is 1.
Mm.
Yes or no? Are you getting?
Yes, sir.
Everyone is getting this part. If I'm going to draw only one ball, let's say this M are red, n minus m are second kind. I'm going to draw one. I will be having only two options, right? Either suppose this is red and this is blue. So either I will get red or blue. Yes or no?
Yes, sir.
So this means what? When n will be 1, this will be Bernoulli trial.
Yes, sir. One
Huh?
trial.
I mean, this will cancel out. N minus 1, n minus 1. You will get this part or not?
Yes, sir.
Sir, in last, can I ask some doubts in 10.3 in the last of the session?
Yeah. We can ask. I mean, you can ask. Okay. So this is something
Okay,
you are
thank you.
getting or not, right?
Oh, Prashant,
So
can you repeat the last concept?
this one,
Yeah.
this
Yeah,
one.
n minus
Suppose I'm
n.
saying this small n is 1. That means what? I will be having only two options, right? It will be Bernoulli trial.
Yes.
Are you getting? See,
Yes.
out
Yes.
of
No.
n, suppose I'm saying I had n balls, right? And m are red, n minus m were some different color. Let's say blue. I'm saying n is 1. Means what? You are drawing only one ball. That will be Bernoulli trial or not? Either you will get red, that means success. Either you will get the blue, that is failure.
Got it.
Got it? So this will be cancel out. I mean, this will become basically 1. Okay. Now, can you relate this variance part and this variance part?
Okay.
Yes.
Yes.
Now, I mean, are you getting something? So one more thing I'm trying to explain here. What if capital N is very, very large to this small n? Then what will be the case?
It will be 1.
Again,
And
Bernoulli. Yeah.
If
it will
your
approach 1, sir.
capital N is very, very large to small n, what it will be?
So n minus n divided by n minus 1 will approach 1.
Yes,
It will
no?
be Bernoulli made.
It will be approach 1 or not?
Yeah.
Yes, sir.
Right? So I can make a statement if the population capital N is very large, okay, large as compared to, sample size small n, then I will say this hypergeometric is it will be about to binomial with parameter n comma small m divided by capital N. Would you agree with me?
Yes, sir.
Correct? Yes or no?
Yes, sir.
Okay. So there are some like if you see the lectures, so those who have seen maybe then they are aware about this. So ma'am have explained with some graph. I mean, she took different values of capital N then small n. You can go with that and let me know whether you are getting or not. So, okay, so far some rough idea is clear or not in different scenario and these two distributions.
Yes.
Yeah, Prashant.
Yeah. Okay. Right. So next one is called something, Poisson distribution. So I will take again some scenario. Then basically there are different scenario to use this Poisson distribution actually. So when Poisson distribution will be useful? So basically when I'm interested in, uh, number of events. Okay, I mean I'm interested to find the probability of a let's say I'm writing probability of a number of events occurring in a fixed interval of time or space. Okay, don't worry if you're not getting the statement. I will take some example that will give you the idea about this. So I'm interested in number of events occurring in a fixed interval of time or space. Let me take some example. Maybe in that scenario, you will prefer to use this kind of. So basically, I'm trying to explain what is the meaning of events occurring in fixed interval of time. Okay. So I will give a heading. So events occurring in a fixed interval of time. So in this case, I will take some example. Let's say I'm saying, uh, let's say, yeah, what I can say, let's say, let me take number of no, telephone calls. So you can see whatever the scenario we are taking here, it's all about discrete. Okay, we took 10 times tossing a coin. We are drawing 2 balls. So we are interested in count. And we are interested that will give you the discrete. Continuous will see in week 12. So suppose I'm saying number of telephone calls received per minute at a call center. Okay. So here I'm interested in what number of telephone calls, right? So this is number of events occurring in a fixed interval of time. I'm interested in per minute at a call center. Okay. So let me take second example. Number of vehicle passing through a, you can say, intersection of a road. passing through an intersection let's say in a fixed interval of time, let's say of 1 minute. I'm interested in 1 minute from through an intersection point, how many vehicles is passing. So what is this? This is the number of events, right, occurring in a fixed interval of time. Time is 1 minute. Okay, are you getting some sort of idea? Okay. Okay, so let me take different, you can say number of people with they are with the drawing money from ATM in 10 minutes, something like that. So let me take another example for this case. In a fixed interval of time, I will take events occurring in a like space, right, in fixed interval of space. So what is the meaning of space here? So let's say I'm saying number of typos. Okay, number of typo. I mean incorrect spelling in a book. Okay. So here, what is this? This is number of events occurring, right? This is your space. Okay. Let's say I'm saying number of defects per meter in a roll of cloth. So this will be, this you can consider as your space, and this is, you can consider your number of events occurring in a like that. Okay. Are you getting this part? Something? Okay. So something you can say, number of suicides like it will be number of suicides reported in a city. Okay. So this here your city is what kind of, it will be in a fixed of space. So I'm talking about in particular space, right? And this is the number of events occurring. Some rough ideas. Okay. The scenario which I'm trying to create here. Yes. No.
Yes, yes.
Okay. Yeah. So thing is this. So what's the assumptions regarding this kind of scenario? So like when we can this is, I mean, in this kind of scenario we can go with the Poisson distribution. Actually, what is the application of Poisson distribution? Whenever you want to do modeling in time, and like basically modeling in time, or you can say modeling with space or something like that. So in Poisson distribution, so there are some assumptions. What are those assumptions? Your events, whatever the events happening, right, they are independent of the time. I mean, basically they are independent. Okay, basically there is, okay, let me write one thing. I will write X follows Poisson distribution with parameter lambda. So what is the role of this lambda? So this lambda is nothing but it's called the parameter of this Poisson distribution, and this is the average rate. And what is this? Okay, can you tell me what will be your X by using those scenario? What should be your guess for this X? Like you saw the for binomial number of success in an independent trials and something like that. So what will be the guess for your X? Yeah, anything. Just go with this. Maybe wrong. It's maybe correct. That's not a problem. Go with. On average, how many success in n trials? Okay. Anybody else? So here we are interested in fixed interval of time and space, right? So can I say my X will represent number of times an event, okay, occurs in an interval of time or space? Would you agree with me now?
Yes.
X I can say or not, because I'm interested. See, Poisson I am using when I'm interested in modeling in time and all, right? So this Poisson distribution, whenever I'm interested, what is the probability of number of events occurring in a fixed interval of time or space. Whenever you usually having these kind of scenario, uh, events occurring in a fixed interval of time or events occurring in a fixed interval of space, you can go with the Poisson distribution. So there is one more thing actually, you can proceed with like why we are getting this kind of I mean, how to move this Poisson distribution actually. First of all, let me write the probability mass function. Okay, so probability mass function, probability x equal to x will be e raised to power minus lambda, lambda raised to power x divided by x factorial. Okay, what is the possible values your x can take here? Anyone, any guess? By using this information, any guess? What should be the value of x?
0 to infinity.
Everyone will,
And
would you correct? No, not n, right? Because we don't know, right? In that fixed interval time, you don't know the upper limit, right? See, x is number of times an event occurs in an interval of time, right? It can be 0, it can be 1, it can be 2, it can be anything, right? We don't know n here. N is not fixed here. Okay?
okay.
And this lambda will always be greater than 0. Okay? So from where this PMF we are getting, actually, I'm not going into the derivation, but I will let you know. Actually, this Poisson distribution is an approximation of the binomial distribution. When, so in binomial distribution, we have two parameters, right? N and P, right? So there are scenario when suppose your N, this N is, this N is large, okay? And success probability P, no, is very small, actually. And such that value of N into P, it will give you lambda, which is finite. So by using the binomial distribution, right? So here from here, P will be lambda by N, right? So binomial distribution, and choose x, p raised power x, 1 minus p raised power n minus x. Then you will replace this, p as a lambda by n, 1 minus p, 1 minus lambda by n raised power x, and we'll do some approximation and all. So this called Stirling's approximation. We are not doing that much derivation here. So just give you an idea. So whenever you have binomial distribution and n is very, very large and p is very small, then value of np will give you lambda, and that form a Poisson distribution. This actually you will apply the limiting property here, and you will get this probability mass function. Okay, so this is something you can keep in your mind actually. So
Can you
and
scroll down a little bit? The last
uh,
part.
yeah, this one.
Can you explain that last limit? Yeah, that part.
Actually, I'm saying for the derivation of this part, right? We have to do Stirling's approximation and all. We have to take limiting property and all.
Oh,
We are
got it,
not,
got it.
yeah. So basically, this form, right? What you will do, limiting of and I mean, I'm not going to do that
No,
mathematics
I
here.
understand, Prashant. Let's not go deep into it. So you're saying that basically when I put all these limits on the last binomial distribution, I'm getting Poisson.
This Poisson distribution.
Got
Okay,
it,
this
got
will. So you will expand this n factorial, x factorial, n minus x factorial. So this x factorial you can see here, right? This part. Okay. Okay. So
Fine,
that is
fine.
something we are not going in that much depth. Actually, that's not necessary as of now. That's important, but not necessary as of now. Okay. So one more thing regarding expectation of and all. So PMF, let me write it again. So it's e raised to minus lambda, lambda is for x divided by x factorial, and limit for x will be 0, 1, 2, and so on. And one interesting thing about Poisson distribution, expectation is also lambda, variance is also lambda. So that is very easiest part of your, Poisson distribution. Suppose sometimes they will not mention what is the, like, normally we are writing x follows, Poisson lambda. They will not write what is the value of lambda. They will simply say x is with mean, let's say 10, something like that. Then you have to find the probability of something. So what you have to do, you have to then think a bit, what will be the value of lambda. Is this fine? Any doubt? Yes, no?
Yeah, fine.
Okay.
Fine,
Let
Bhushan.
me take one example. Maybe that will give you that should give you a clear idea about this Poisson distribution. I will start with a very simple example. Suppose I'm saying a car hire firm. There is a car hire firm. No, it has two cars. Suppose, and which it hires. Let me write the question. Which it hires out day by day. The number of demands for a car on each day. Okay, let's say I'm going to mention is distributed. This demand is distributed as a Poisson distribution. I told you that let's say with mean 1.5. Okay, so by using this, can you guess what is the value of lambda? Lambda is 1.5. Yes or no? Suppose I asking what is the probability that, okay, first of all, how will you define your x by using this information? What will your x here? It's basically number of demands for a car on each day, right? Or basically on any day. Yes or no?
So 0, 1.
Yeah, it will be 0, 1, 2, and so on. Suppose what I'm asking question. My question is, what is the probability that probability of days on which? Okay, let me write probability of days on which neither car is used. So, are you getting? So X represents the number of demands for a car on any day. So what will be this case? Can I write probability X equal to 0?
0.
Okay. In general, what will be the probability of X equal to X? It will be e raised power minus lambda. Lambda is for X divided by X factorial. And where lambda is what? And I told you
1.5.
expectation of X is 1.5. It will be e raised power minus 1.5. 1.5 raised power X divided by X factorial. Right? And I'm asking probability X equal to 0. So it will be e raised power minus 1.5. 1.5 raised power 0 divided by 0 factorial. This will become 1 and answer will be e raised power minus 1.5.
Yes.
This is something you can calculate with I mean with sorry, calculator and all. Okay.
Yeah. What lambda represent here?
Lambda represents the average.
Mean.
Yeah, mean.
Okay.
Okay. Yeah, I will take one more example that will give you a clear idea about this. Okay. I mean the issue regarding your lambda actually.
The E represent here.
Sorry?
The E.
E is the exponential part, something.
Okay, exponential.
Yeah, it's exponential. Okay. Suppose I'm saying question is, let's say the number of cats, okay, that are killed, on a particular, let's say intersection or particular, road or particular road in, let's say in others in any city, let's say, okay, what in a city or in any one day. Okay, I'm talking about in one day. Let's say I'm saying this can be modeled as a Poisson distribution with parameter, let's say 0.4, for example. Okay, I will take you the scenario. Suppose my question is, what is the probability that exactly two cats are killed on a given day. Okay. Then what will be the value? I mean, how will you proceed? I will write probability of x equal to 2.
Yes.
Right? It will be e raised power minus 0.4. Basically, it's e raised power minus lambda raised power x divided by x factorial. So lambda is 0.4, right? So 0.4 raised power 2 divided by 2
factorial.
Now, this is on a given day. Now, let me change the scenario. You will get idea how lambda can change. Suppose I'm asking, what is the probability that exactly 2 cats are killed over a 10-day period on the road, on that particular road. Now tell me whether value of the lambda will change or not.
Yeah, 10 times lambda. No.
10 times lambda, right? Because this lambda, if you see in this scenario, what was the case? It was for
only 1 day.
For 1 day, lambda was 0.4. Right? If I'm asking about probability for 10 days, lambda will be let's say lambda transpose will be 10 times that 0.4, which will be 4. Would you agree with me?
Yes.
Right? So now, I mean, we have to be careful. Basically, this lambda is a kind of, you can say it's a rate parameter. On an average, it's a rate parameter. Okay. So it will be e raised power minus, suppose it will be probability, let's say x transpose equal to 2. It will be e raised power minus 4 raised power 2 divided by 2. Is this clear?
Oh, clear.
Yeah.
Right? Now you can get the idea how lambda can change.
Yes, it's number of days.
Yeah, number of days. I will take one more scenario. You will get idea how to, I mean, I told you one scenario, right? From binomial to Poisson, n is infinity. I mean, infinity means very, very large. P is very, very small. Value of NP will give you lambda. That's not in our course, but I will just I want to give you a flavor for this. Suppose I'm saying, I'm taking one scenario. There is an insurance company, and that insurance company insures 4,000 people against loss of both eyes in a car accident. Should I write or is it okay to speak? If you are getting. Okay, let me write.
Just put the numerals alone.
Okay. Suppose I'm saying there is an insurance company. Okay. That insurance company insures 4,000 people. Okay. Let me write one line, then it will be clear. Against there is a loss of both eyes in a car accident. Okay. Now, what I'm saying, suppose there is a historical data based on previous data, rates were computed as, let's say, on the average, 10% in 1 lakh people have car accident each year. So what will be my probability P? I'm talking about 10 accident, I mean 10% out of 1 lakh will have a car accident each year that result in this type of injury. I mean, they lost their life. Yes or no? Okay.
Yes.
Okay. Suppose I'm saying, what is the probability that more than 2 or more than 3 will I mean more than 3 of they are going to get insurance from from the company in a year. I'm talking about, let's say, 3. So can you see here, n is large, 4,000, and this p is very, very small, right? Okay. In this case, is it okay to proceed like this? 4,000 C, I mean NC0, right? So is it okay? Would you like to proceed with 4,000 C0 and this 10 lakh something, this with this probability powers 0, then 1 minus probability will 4,000. That's not a good thing, right?
Yes.
Are you getting what I'm trying to say, right? Yeah. Then you have to add 4,000 C1. That's not a, okay. So that's why we are moving with this Poisson distribution. We have already, if you can search, or if you are interested, I can give you the derivation part. So we are applying limiting property there itself. So after applying the limiting property, we are getting that formula. Okay. Are you getting what I'm trying to say, right? Is it it's not a good thing to do for like something like this.
Yeah, till 4,000.
Yeah, it's very, very, very tedious task.
Yes.
And there is a lots of possibility for making error. Correct? If you'll do 4,000, yes, this is very big task. So that's why we are applying limiting property and all. We are getting the Poisson distribution. So whenever you have this kind of scenario, n is large, p is very, very small, then how? See here in this case we don't have value of lambda. Then you will do n into p, which will give you the value of lambda, and which is finite here. You can cross check which is greater. Fine. I mean, some sort of rough idea. Okay.
Okay, Ji.
So there, the last point,
Mhm.
where in that case, when you're applying Poisson, you're finding the lambda by n into p. That's what you said.
That's the rule. I mean, that's the something we
Got
got
it.
from.
Got it.
Okay. So n into p will give you value of your parameter lambda.
Sir, I have a doubt in 10.3 in question number 3 and 4. Can you explain it, please?
Okay, so before that, everyone got the idea. This week 11 is okay. Some sort of you got the idea.
Yeah, Ji. Okay.
Yes,
But
sir,
it's
yes.
comparatively it is length lectures.
Comparatively, sorry, I didn't get.
Little bit lengthy lectures.
Yeah.
Okay.
So week 10 was a bit easy.
Yeah.
Week 9 okay,
Simply
but 10
two concepts
11
are
is.
discussed in Big 10.
Yeah.
But
So
anyway,
binomial, Bernoulli,
this
and then this
hypergeometric. Actually,
hypergeometric,
these are kind.
Poisson.
These are the important distributions actually.
Yeah.
Okay.
I mean, in lots of scenario, you will find this kind of questions.
So it is only for a discrete random variable.
Correct. So you can see discrete is what we are interested in count, right? So whenever you can see we are interested only in count part, right? Number of head in 10 trials,
yes.
Number of balls out of these, okay? So these are discrete. Whenever we'll see, we'll move to the continuous and week 12. We'll see the continuous scenario. I mean, we are interested in, length of time, let's say life of battery, okay? Or life of a bulb. So life of bulb is what? It's a continuous process, right?
Yes.
Yeah, measurement is done.
Measurement is there, right? You can't count life of a bulb, amount of milk or something. We'll see.
So integration will be there.
In stats 1, no. Without integration, we can go ahead because in stats 1 we are dealing with very, very basic problem. If you know the integration, you can do the same problem with the integration also. That's not a problem. Integration mostly we will be using in stats 2 course.
Yes. That's what stat 2 I'm saying. Continue for continuous.
No. For continuous, we have in week 12. But if you don't know integration,
in stat 2.
Stats 1, week 12. We have continuous.
I'm talking about the stat 2.
Yeah, in stats 2 we have to do integration. Without integration.
That's what I'm saying.
Yeah. In stats 2 we have to do integration. Okay. So who asked this question? 10.3.
Yes, sir. 10.3 question number 3 and 4.
Okay, tell me what I will give you the idea behind this. Maybe you can proceed. What was your approach? I would like to know. What was your approach?
Sir, actually, first I have solved this question with approaching the probability that finding the probability of 5 women from 20 junior developers which got promoted one by one.
Okay, so I will tell you the scenario. So you can do this question first of all with hypergeometric directly.
Okay.
Since in week 10 we don't know hypergeometric, I will tell you the both approaches. So out of 20 juniors, 8 are men, 12 are women.
Yes, sir.
8 are men, 12 are women. So you can find this is your capital N, this is your, this is your small m, this is your capital N minus m. Yes or no?
Yes, sir.
Can you relate?
Yes, sir.
5 juniors are to be promoted to the senior level. What is the expected number of women? So I'm interested in women. So I took a small m as a 12 women. So what is n? N is 5. So what is the expectation of x? We know hypergeometric n into m divided by capital N. So n is 5, m is 12 divided by 20. 3 is the answer.
Yes, sir.
Okay. Now, since we don't know hypergeometric, suppose in week 10, how you can proceed? So X represents what? Number of women promoted to senior level, right?
Yes, sir.
First of all, can you tell me what is the possible value your X will take here?
Yes, sir. 0, 1, 2, 3, 4, 5.
Correct?
Yes,
Now,
sir.
if you see, what is the probability for X equal to 0?
Sir, probability for X equals to 0 will be all men's are
Correct.
got
That means
promoted.
8C5.
Yes, sir.
And what is the total case?
Yes, sir.
20C5.
20C5. Yes, sir.
For one.
It will be, sir, 8C4 and
First of all,
12C.
12C1, 8C4 divided by 20C5.
Yes, sir.
For 2, 12C2.
Yes, sir.
8C3, 20C5.
Yes,
Similarly,
sir.
for 3, 4, and 5.
Yes, sir.
To calculate the expectation, what you have to do? It will be 0 into this probability, 1 into this probability, 2 into this probability. I mean, you have to add all those things. Got it?
Yes, sir.
Okay. Now, come to the next question. So, there are 1,000 mobile phones in a mobile wholesale shop, with of which 100 are defective. Right? A retailer buys how many? 20 mobile phones from wholesale shop for a total price of 2 lakh rupees. Okay. Retailer gets 2,500 rupees profit if the mobile phone is not defective, and 10,000 loss if the mobile phone is defective. First of all, what is the probability for being defective?
Sir, for being defective, it will be 20 for a
100
mobile.
divided by, correct?
Yes, sir.
This will be the probability, right? 100
Yeah, that
divided
is
by 1,000,
0.1.
that is 1 by 10. Correct?
Yes.
Now,
Point.
in total, that retailer buys 20 mobile phones, right?
Yes, sir.
So he buys how many phones? 20, right?
Yes.
So let's talk about ith phone. Means I'm talking about, let's say, single ith phone, right? So what will the value of this xi? If that phone is not defective, he will get 2,500 profit. That means what will the value of xi? 2,500, right?
Yes.
For not defective. So what will the probability for not defective?
1
It is
minus
9 by 10.
1 by 10.
9 by 10, right?
10. Yes, sir.
And if phone is defective, he will be loss of 10,000 rupees, right?
Yes, sir.
So X will take minus 10,000 for loss when it is defective.
Yes, sir.
So what will be the expectation for a single? I'm talking about ith phone, a single phone, not for all 20th phone. What will be this expectation? 2,500 into 9 by 10 minus 10,000 divided by 10.
Yes, sir.
Okay, so what will be the value of this? 25 into 9. Can you calculate?
Yes, sir. Sir, this calculation is come out 1,250.
All
Total calculation. Yes, sir.
1,250. So now you can see this 1,250 is for what? For a single phone, right?
Single XI.
And that retailer, how many mobile phone he purchased? 20.
20.
So this for
Multiplying.
single. So for 20, you have to add all these expectations.
Yes, sir. And
for
the
20th phones, it will be 20 into 1,250. Whatever the value you will get. So 150, 125 into 20, that means 25,000 if I'm not correct or not wrong.
Yes.
Yes, sir. Correct.
Is this
Correct.
answer?
Yes, sir.
Yes, sir.
Sir, in question number 3, can we use the same approach that we can find the XI, one single XI expectation, then
No.
we can multiply.
How? See, that's the difference you have to find. See, in this case, success probability is same for each phone, 9 by 10, 9 by 10, 9 by 10 if it's not defective.
Yes, sir.
Right? But in this case, for each trial, your probability is getting changed, right?
Yes, sir.
That's what we have seen in case of hypergeometric. Yes or no?
Yes, sir.
Clear?
Yes, sir. Thank you, sir.
Okay.
Prashant,
Yeah.
one small question on the last question.
Mhm.
Can you share that screen again?
Yeah, sure. Give me a second.
So this question was asked, I think day before yesterday. I'm just going to reiterate. Someone asked this day before
Okay.
yesterday. What is the practical real-time understanding of
E of x square when E of x is given. Like in this case, we have E of x, we have defined it, correct? How do I interpret E of x square here? The same scenario.
So, like, okay, first of all, what do you mean by expectation of x? What's like?
So right now, expectation of x is the profit I make by when I'm just retailing one mobile. I'm saying I'm taking one mobile from wholesale and retailing that one mobile. The expectation of profit is my expected profit is E of x. In the same real-time example, what is E of x square?
No, that's okay. So what I'm saying, what E of x represents?
Yeah, E of x represents the profit I get for one mobile.
Expected profit, right? So if, first of all, can I say this? First of all, expectation of x is what? It gives you basically. Let me talk. Maybe that will give you idea. Suppose x is taking some values x1, x2 up to xn, right?
Correct.
And probability of each xi with, let's say, p1, p2 up to pn.
Okay.
Right? So suppose this is what? This is something you are describing your random variable.
Correct.
Correct.
PMF.
I mean, okay, PMF, right? Suppose you want to explain or you want to describe your random variable in a single number. Then how will you proceed?
You want to represent my random variable in a single number.
Single number. So what should be the best approach?
That's expectation, correct?
Yeah, that's expectation. Yeah, that's what I want answer.
Okay. That's expectation, correct?
That's expectation, right?
Yeah.
So what is the x square basically? What is the meaning of x square?
I'm just gonna say what step I'll follow. X square, I'll just square all the random variables.
All the random basically.
But my probability will remain the same.
Probability will basically x square is what? One of the function of your random variable.
Correct. Function of a random variable. Correct.
Okay. If you have function of your random variable, then you will be having some PMF.
Yeah, but that doesn't change. The probability doesn't change. Okay. Yeah, I'll have a PMF. Yes.
PMF, right? If I want to explain that PMF in a single number on an average, then what should I do? You can think x square as y.
X square.
Let's say
okay,
I'm
that will
about
be E of y, and that will be E of x square.
E of x square, right?
But how do I connect it to a real world example is my question.
Okay. Let me think a bit. Okay, this idea is okay.
This I understand.
This understood, right? So basically, I want to explain my random variable, whatever we have, in a single number, right?
Got
so
it.
let's think. Suppose x is represent your height of some student in a class, something like that. Okay, so mean height will be some centimeter, whatever.
Correct.
Let's say some.
Correct.
I got expectation of x as some, let's say 150 centimeter, for example. Okay. But if I want to calculate the variability, then how we can proceed?
You're saying variability. Okay.
Variability.
Then I have to apply the.
Correct. So what is the variance?
E of x square minus.
E of x minus mu whole square. And this formula we are getting expectation of x square minus expectation of x whole square, right? After expansion of this part, right? Yes or no? This is clear, right? So actually, why we are doing this one? Let's try to understand. Actually, I have to think a bit the question you have asked. Okay, let me say, suppose there is two colleges, college A and college B. Okay, and we have been given some, let's say, these 5 numbers, and I have these 5 numbers. Let's say these are cell package of some 5 students in 10 lakhs. I mean, this is the 30 lakh and 30 lakh 30. This is 10, 20. What is the average? 3.
Here it's 3.
Here.
Yeah, here also it's 3. Variance is giving us that idea of the spread and all. Variances. Okay. Yeah, correct.
We can't say here both colleges have the same performance.
Correct.
Like, we can't say like so we can't make a statement in both colleges performance of students are same. Correct. Right? But correct. On an average we can say yes, but both are in reality there is variability, right?
Correct.
Variability correct. We are checking from where for each with their average.
Correct.
Okay, so actually there are lots of questions. See, we can take, why we can't take the absolute difference? We can take, right? Absolute difference from mean we can take or not?
Yeah.
Okay. We can take something else. Yes or no? But why we are taking x minus mu square itself? Any idea?
Because square will reduce the error. Something I've
Forget about error. So let's see. Yeah, that's okay. Thing is that we have to give the weightage of that numbers also. Weightage means if you subtract 1 minus 3, it will be minus 2, right?
Yeah.
If you subtract 2 minus 3, it will be minus 1.
Correct.
So that is something. So if you are saying practical implication of this, so as of now, what I can think, first of all, it will help in calculate the variability.
The variance. That we are on the
okay.
same page. Yeah.
Okay.
But how do I intuitively think of E of x square when I have an intuitive understanding of E of x? That's
okay. So x is something, suppose taking value 1, 2, 3, 4. X will be square of that.
If you want, I can take it even in the next session. But this question was it is not my original question. It was someone who was asking it in the last session.
Yeah, that's okay.
I
I will think a bit. That's
yeah.
not a problem.
Also, you can if you can give us idea on what does E of x the whole square also mean, like what does square, because E of x and E of 2x I can intuitively understand. What does E of x and E of 2x gives. So
no worries. I
yeah.
will think and I will try to come up with some real life examples so that we can get some idea. Okay. Thanks for this question. I will come up.
Thank you, Prashant.
Yeah.
Also, Prashant, one more thing. I just gonna take 10 seconds. See, I was like working on that extra activity 4. And I was like looking at a real time data of FIFA data for the number of yellow cards. Exactly the same thing what you said happened there. I was trying out different models, binomial distribution, Poisson.
Okay.
And since my n was large and the p was very small, both my Poisson curve and the binomial curve like merged together. But they were on the same graph.
Yeah, that's
I was searching where was this distribution, and when I saw it, I was like, and when you said, I was able to connect so many things over that part.
Yeah, so it's a very important thing. Actually, see, if you'll do calculation manually, right?
Can you give me share access, because I can show it so that I think people will be able to
actually, I
understand
don't have access with the studio team is
Oh,
handling
okay,
this
okay.
kind of thing. Anyway, we can check
It
your
was very like it was an
Yeah, so-
innovative time thing.
yeah, in today's,
Surprise
see,
moment
you
for
can
me.
if you are familiar with collab file or other things, so you can do those calculation which I took, right? 4000 C0 something like that. So at
Yeah,
that,
that exactly I did it, but by
yeah,
mistake. I was like, I thought it was a mistake. How can
No, no,
Poisson
no.
and binomial be same? But
No,
when
no,
you
no, no.
said now, I was able to understand. Oh, that's because n and p are like n is large and p is very small.
Correct. So actually, we are not doing that derivation in this course, but if someone of you interested, I can do the derivation and share with you. But yeah, so idea is behind that actually. Whenever you will do that limiting property, right? Limiting of n tends to
Yeah,
and
yeah,
all,
yeah.
then okay.
Yeah,
Okay,
thank
okay,
you
all
so
right,
much.
all right. Then we can wind up and we can beat in the next. Okay. I'm hoping you got the idea of this week 11. Okay.
Yeah.
Okay. All right. All right then. Thank you all. Bye.
Thank you guys. Take care. Bye.